Thank you and good morning. It's a privilege for me to address such an audience. It's a combination of car guys and electrical engineers, so the smartest guys in Detroit. So I'm definitely very happy to be offered this opportunity, and I'd like to thank Mentor Graphics for this, and also our friends at SAE International. I also act as a Vice President SAE Automotive for the automotive sector, so certainly it's a great opportunity for the interest of various companies and organizations to come together this morning and speak about the topics that were mentioned in the introductory speech here. The title of my presentation is Challenges of Virtual Analysis Adoption in the Automotive Industry. And I think we would all agree that there are major challenges. And I will go through ways and levers to address these challenges, but I'd like to make also a connection between virtual analysis and efficiency. That's going to be the backbone of my presentation this morning. I see a very strong impact of the virtual analysis on the efficiency of what we are doing in the auto industry, both from the product perspective as well as from the processes and business perspective. So we'll get into the details of that a little bit more. So that will be the first bullet point on the agenda. The second one, a historical perspective on efficiency in the auto industry, the way it evolved over time, maybe from the 60s up to the present time. Challenges to becoming efficient. Again, if we start with that, we can certainly identify virtual analysis as one of the problem solvers, so to say. And then what prevents us from successfully implement the virtual analysis in the auto industry, and a couple of thoughts relate to that topic. The quote at the bottom is pretty interesting. It's by Peter Drucker, famous economist, certainly involved with the auto industry. And it says that efficiency is doing better what is already being done. That's one potential interpretation of efficiency, certainly a lot of truth in that. Again, the motivation for virtual analysis, the way we see it, is increased efficiency. And if you think about it, it's everything from the very strict interpretation of product efficiency up to the way we are successful in the auto business by manufacturing and selling cars. The efficiency is an adjective, and its definition is the first sentence there: achieving maximum productivity with minimum wasted effort or expense. If you adapt that to the auto environment, we translate it into profitably manufacture and sell vehicles that meet and surpass customer requirements in a cost-effective manner with sustainable use of energy and resources. I'm using a couple of examples that again link efficiency and, if you want, virtual analysis at the component level and at the vehicle level. On the right side, you see the 8-speed transmission that is installed in some of our vehicles, in the rear-wheel drive vehicles. From the virtual analysis perspective, the people that are familiar with the topic, they know that within a transmission in general, and specifically planetary, you have a lot of degrees of freedom that you can combine. In this particular case, the number of combinations where virtual analysis can be used in the concept development phase and concept identification or definition is 10 to the power 9, because the various architectures that can be adapted. So there is no question that virtual analysis played an extremely important role in defining that component architecture. From there into the vehicle integration and up to the 31 mile per gallon highway EPA result that actually is pretty impressive for a rear-wheel drive vehicle of that size, virtual analysis followed us through the process and helped us increasing the efficiency, again, from the product through the process. With such an emphasis on the efficiency, I just wanted to introduce, if you're not familiar with this already, the topic of the SAE 2013 Congress, World Congress here in Detroit. It's achieving efficiency, and we are Chrysler is proud to sponsor the event along with the Tier 1 strategic supplier, which is ZF. The historical perspective on the North American market, picking a year, 1962. At the time, the sales volume was relatively large, roughly half of what we are selling today. And it was divided, the market was divided essentially between General Motors, Ford, Chrysler, and Volkswagen, and other smaller manufacturers had some level of penetration on this market. The interesting aspect is the process efficiency that was the emphasis at the time. Certainly the big three had a great advantage from that perspective, economies of scales or efficiency of scale, the way we put it here. And the emphasis was certainly on business, maybe manufacturing process to a certain extent, but certainly not on the product. For the others, it was difficult to compete on price given the efficiencies of scale. And the consequences of inefficiency were maybe more forgiving. The market was more forgiving and the economic environment. So it didn't mean at the time going out of business if you weren't really at the top in terms of efficiency. But making this more specific to the product, a great car, Chrysler Imperial, the quote at the top is pretty interesting, extremely comfortable, great car to drive on long trips. But when you look at the fuel consumption, for instance, the 5 to 7 miles per gallon city and 8 to 10 miles per gallon highway, certainly you can tell that there was no big emphasis on that aspect. Again, the car from the performance perspective, as a comment related to the drivers of the market at the time, 350 horsepower and 637 Newton meter of torque, that was certainly impressive even for today's environment. In 61, from the process efficiency perspective, and again, more business efficiency, the mean age of the automobile was 5.2 years, so certainly a lot of turnaround and favorable from the economic perspective. So, changing rapidly to today's environment, we can say that we have the big five. It's a known state of the business here in the US now, and you can see the market share is relatively close between these five manufacturers, and the consumers are not necessarily bound to a certain brand. Certainly the brand aspect, and as you will see in the coming slides, other consumer behaviors have changed drastically over time. In today's environment, if we look at the buying criteria, the most significant change facing the industry is the shift in consumer buying criteria that goes beyond and is unrelated to vehicle performance. The emphasis is increasing on environmental safety, personalization of the vehicle, traffic congestion avoidance, navigation systems certainly help, alternative transportation. So these factors will have a major impact on what people choose for their mobility needs. And the traditional buying criteria that we mentioned and so reflected in the 62 example with the Chrysler Imperial, they start to fade. The price, reliability, and brand will have much less an impact in the decision process as we move on. On the right side, you see between 2008 2020 kind of prioritization of the various buying criteria, and you can see the fuel efficiency being extremely important, eco-friendliness, traffic congestion, and so on. So a pretty interesting shift in consumer behavior. Why are we bringing all this up? Because again, this drives ways and solutions to be efficient in the auto industry, and in our view, all that is supported by virtual analysis. So that's the link that, and as I said, the flow of this presentation and the message of the presentation. In terms of the increasing customer expectations and regulatory actions, we are all familiar with the fuel economy aspects, which again are a pretty contradictory topic from the perspective of consumers' ability and willingness to actually pay for the technology that offers improved fuel economy. The safety, which in today's environment has to come at no compromise related to performance and fuel economy. Reliability and cost of ownership, reflected in warranty numbers, extended life of the vehicle, and number of visits to the dealer. And then the comfort features, power seats, automatic temperature control, heated and cooled seats, and vented seats for that matter, audio systems, and infotainment. I brought this up because, in our opinion, all this offer opportunities for the use of virtual analysis tools. Those are areas where we think, again, there is a certain need, an unaddressed need for virtual analysis in the very early, either concept development or early development and validation phases. Another challenge to becoming efficient is the global expansion. And we all know that the climate, roads and duty cycles, regulatory requirements, and the fuels play an extremely important role in how we design and sell vehicles in these markets. And with the complexity and diversification of markets, I think virtual analysis, and we prove that actually allows us from the beginning of this initiatives to actually be efficient and essentially save a lot of money. The other obvious challenge is the vehicle complexity. On the bottom left, we have the driveline powertrain of a vehicle in the marketplace. Currently, it could be our L platform, the 300 Challenger, or it could be the trucks, the light-duty trucks, the 1500 Ram, or any other. The interesting aspects are the interactions between the various powertrain driveline vehicle components, and they are reflected in this case into the functionality related to disconnecting front axles for increased efficiency, the overall transfer case control for the same purpose, keeping more elements stationary in the driveline for minimizing losses. And again, this whole work together between the various components, which does include, in our early assessments, an overall vehicle energy management, which again, as mentioned also in the mentor graphics presentation, is one of the major challenges in today's environment. And that's, from my perspective, one area where I would expect a lot of dialogue and interaction during the conference. I'm using also these events and opportunities, quite honestly, to expose our needs and expose our current concerns, and this is one of them. As I said, vehicle energy management is very high on our priority list, and I think I would be very, very happy to have a dialogue with anybody in the supply community on that topic. Moving to the challenges to successful virtual analysis tool adoption in the auto industry, we created a summary slide, if you want, with all the factors that influence this successful introduction. Certainly the strategy, the people, partnership relationships with the suppliers, no matter if they are component suppliers or maybe engineering services suppliers, processes and tools, and the technology. Going into each of those topics, starting with the strategy, there is a tremendous need for senior leadership commitment to utilizing virtual analysis tools. And I think we've been exposed through our careers to this type of challenge because the virtual analysis adoption comes with a pretty significant financial commitment by the company. And certainly having the senior leadership supporting and understanding the benefits is key. We all ran business cases that prove the benefits of virtual analysis in one or another project, but this has to go beyond that point. It has to become part of our corporate culture, and that's what we are trying to drive at Chrysler. And certainly the exposure of the top management to this is extremely beneficial. The alignment of virtual analysis resources with vehicle programs and plans. From the planning perspective, as you know, there is a lot of overlap in terms of the launch of various vehicle platforms, and they compete all with the same pool of resources for the virtual analysis. It would be too idealistic to think that you could, make your business plan based on the availability of virtual analysis. But the key is to have virtual analysis available in the early phases of each program. So that's our plea here, and I'll go a little bit more in the details of that. The long-term vision for virtual analysis, this cannot be an opportunistic, kind of spontaneous type of event every time when we have a problem, every time when we try to, if you want, passively address an issue that concerns us. It has to be proactive, it has to be forward-looking, and it has to encompass a pre-comprehensive vision. So that's the way we try to approach it. Again, putting together bits and pieces of analysis tools that are incompatible with each other. We've done that in the past, and certainly it's not an efficient way. And then the plans for integrating the virtual analysis across a global organization. I looked at the participants list. Certainly we have the big three here, which are all global companies. We have the big tier ones, and essentially everybody's global these days. So you understand the challenge and the requirement there to try to maximize each area's strengths when you have various locations around the world. On that note, what we've done over time is actually try to map the various locations around the world, as I said, in terms of their strengths and specific interests. And virtual analysis can be applied in all these disciplines that are listed there. In this particular case, we picked only the European locations, India and China. Obviously, US comes without any further explanation. We have a very diversified set of tools in the US locations, but that's an attempt actually to try to maximize efficiencies. And what we've done is actually at each location, if you look at the bottom of this chart, we looked at the virtual analysis capabilities, virtual analysis competencies, the tool sets, and then ultimately we designate technical references for each competence around the world. So that was our approach to a global virtual analysis organization. At each location, we ranked the tools from the perspective of needs in the local market, as well as from the perspective of if you want, their relative strength relatively to the other locations. Again, we don't want to do virtual analysis for the sake of it, so that's why I mentioned the relevance to the local market needs is extremely important in a global approach. The other thing that we re-emphasized was the presence of virtual analysis, as I mentioned before, in the very early stages of the DVPNRs. If you think through your business process and if you think about how you're doing again, product development at each of the companies present here. I would be very interested, and maybe we'll have a dialogue afterwards. Is there a virtual analysis section in your DVPNR that precedes actually the equivalent of the S0, S1 type of development? Are we always consistently, trying with or starting with virtual analysis in terms of getting some answers, maybe in the concept development phase as well, before we start testing components? So that's, the honest answer, even in our case, in many cases, I think we don't do it consistently yet, but that's the aspiration. The virtual tools and processes need to capture and understand the increasing vehicle system interactions. That's another very important aspect that we consider now. Again, maybe specifically from the vehicle energy management perspective, that's something that we need to see reflected in the capability of the virtual analysis tools. Robust relationship between objective measures and subjective ratings to connect virtual and physical realms. The challenge there is, obviously, we get a lot of market input that is not quantified in metrics that can be used directly in virtual analysis in order to give us some guidance. So that's another big challenge that you're probably all familiar with, especially in the areas that I mentioned at the beginning, items related to comfort, items related to interior design, and so on. And lastly, the utilization of processes that bridge physical testing and simulation with a classic example of hardware in the loop. and I'll have a little bit more information on that. But on a very positive side, I wanted to also use an example of successful implementation of virtual analysis. Our friends at Fiat Group Auto, with whom we collaborate very strongly these days, and certainly they were part of that global virtual tool assessment that I mentioned before. They developed the Fiat Bravo, a very successful car in the European market, by using extensively virtual analysis. And what you see here is on the left side of that diamond point, you have the traditional S0 equivalent and early development. On the right side, you have the PVP and PS phases, the equivalent of S1 and S2. I'm sure that the terminology is relatively common, certainly in General Motors, but Ford uses the same term. So the idea here is that, as you can see from the total of 655 tests or targets in terms of analysis, both physical and virtual, that were addressing areas like safety, operational strength, NVH, aerodynamics, HVAC, and so on. Out of all this validation activities, if you want, the 655, we performed in the initial phase 442 in a virtual way and only 66 in a physical way. That allowed us actually to prioritize for the actual testing in vehicle, which occurs on the right side of the diamond mark there, to prioritize which will be the first tests, physical tests, the 168, which are actually the remaining, if you want, validation activities that weren't addressed in the development phase through virtual or physical testing. And then we did once physical testing. So, in summary, I don't want to spend too much time on this, but instead of doing 3 times physical testing throughout each of these phases, S0, S1, S2, we essentially did once physical testing and a very good virtual validation. So that worked out well, and as I said, this was kind of a successful example of implementation of virtual analysis at the vehicle level. Hardware in the loop, we emphasized that so much at Chrysler that essentially we were at the time also a service provider. We don't have capacity anymore, but that was an interesting aspect of our business. We could have addressed somebody else's activities at a certain point in time when we started this initiative. So, but engine control in the loop, transmission control in the loop, and so on, those are common approaches these days. The technology, I cannot emphasize more the need for a very good vehicle energy management tool. And that's, as I said, the focus of our development. Data management and data mining, there is need for sifting through all the marketing information that we are getting from various areas of the world, and the comparison of those with what we have in the US or NAFTA markets, if you want. It's interesting when you go to damage analysis for various components and you see the ability of the tool in various components to quantify that. It's extremely impressive, and it's extremely useful as well, and saves tremendous money for the development process. Characterizing operating environments, another challenge. This is the summary at the vehicle level, opportunities where we can improve, and there are bullet points on this slide, but certainly they have a lot of background behind. Vehicle benchmarking, sensitivity studies, DFSS in an automated fashion. I mean, that's another very interesting aspect. And then the simulation of fuel consumption, which we all do, but we all think it can be done better. Thermal and fluid systems, again, very relevant to the energy management, and then the aspects of controls. The output of this is certainly a good quantification in the early development stage of the vehicle in terms of energy requirements and the distribution of energy losses within the vehicle. And that's an example just to show the relative proportions in a specific vehicle. But you know how important this is when you need to certify the vehicle, and you rely heavily on virtual analysis for defining your control and calibration for the powertrain or for the overall vehicle. In terms of the software architecture and the optimum tool for vehicle energy management, there is a lot of potential in MATLAB and Simulink-based simulation. We think that we could ideally have a core of this software that addresses, if you want, the inputs from various modules, and this is where the challenge comes for the supply community to be able to make those interfaces, or these modules actually interfacing very well with the core. I would like to challenge and invite the supply base to help us with discrete models of at the component level that have the, if you want, pin connection to what we need in terms of the overall simulation tool. In this case, AC modules, cabin modules for the airflow, hydraulic simulation tools for coolant circuit, engine oil circuit, and so on, transmission, the driver module, vehicle module, a lot of well-known challenges that we thought could be addressed with this overall architecture. And it becomes even more prevalent when you talk about hybrid powertrain efficiency, because in that case you have also the added challenge of maximizing the energy recovery. So modeling energy recovery systems, regen systems, that's the added complexity in that case. So what certainly increases the challenge for us as well is the diversification of the technology. We try to capture here the various technologies that will be present in 2035 with the relative comparison between tank to wheel in terms of fuel consumption. You use the European metrics, liters per 100 kilometer, and you see the very significant benefit of the BEV technologies. By 2035, we also made an attempt to quantify the well-to-tank, if you want, energy flow, because certainly it tells a little bit different story if you look at the BEV contribution to greenhouse gas emissions. So again, another challenge in terms of virtual analysis to be able to quantify this. And we all know that emissions are one of the biggest challenges actually these days in terms of simulation. Thermal management, it's a small piece, a subset of the energy management, and certainly this is just an example where we found the right balance between the cabin heating or ACC control and the overall powertrain thermal management. And as a kind of transition to the other parameters that influence the successful implementation, the people, we concluded that CA engineers, I mean, it's a two-way communication here, and we need the CA engineers to think and act like product engineers, and the design release engineers and management be familiar enough with the virtual analysis to make significant product decisions based only on analysis data. It's a matter of trust, it's a matter of confidence that can be gained over time, and certainly we have to work strongly toward this goal. In terms of partnerships, we are in the business of designing, developing, and integrating powertrains and vehicles, and certainly the analysis tools and processes are key enablers. A couple of comments on this. The component and subsystem modeling required to build the overall vehicle system. And again, that's similar to the comment that I made before regarding the contribution of the supply community to this. In the virtual analysis world, the most effective learning and growing together often occurs face-to-face. So that's why I think, again, the Mentor Graphics initiative is really great, because it gives us all the opportunity to talk about these things and meet and understand what concerns us. More software features does not always make the better for the better software. We all learned that the hard way, unfortunately. And then there is no further definition required for partnership. It's just that, partnership. So I will conclude my presentation with a summary, which certainly states that The virtual tool adoption, the successful one, requires simultaneously addressing all the key enablers. And going through this, on the people side, I already mentioned, if you want cohesive thinking and if you want the good work relationship between the CAE and the product release departments, as well as the partnership with the supply community, suppliers and OEMs that need to jointly find the best way to find and utilize the required expertise. On the process side, this robust relationship between objective measures and subjective ratings, which we all face in the automotive industry, that is required, and we have to improve on that in order to connect the virtual and physical realms. And on the technology side, the emphasis has to be given to software and computing power. The HPC, high computing power topic, I bet it's very current in everybody's minds. And the data management and data mining, data storage in general is a big topic. And then ultimately the strategy. At the top level, there has to be a consideration related to the ability to factor in virtual analysis in the very early stages of product development for each automotive product. So with that, I'd like to thank you.